What is up, guys? Today we're gonna be doing these exercises. So yeah, let's begin with the first one. So this exercise is asking us to solve this chunkers, and they're kind of difficult because we can do it by hand, but it's up to the 50th power, which is kind of an issue because time constraints and all. So I'm gonna show you the best way to do it. So the best way to do it is with the polar form and with how is it called, the Moivre's theorem? Yeah, the Moivre's theorem. So how do we do this? First of all, we're gonna start off by writing the exercise, obviously, because otherwise, yeah. And now we're gonna try to do this. So to do this, we're gonna apply the polar form of this. What does a polar form look like? Well, we know that set can be equal to a plus bi, right? But that can also be equal to r cosine of angle plus I sine of angle, right? That we get. So, what happens if, for example, we have, say, sit equals abi to the power of k, right? What we do here is going to be r to the k, yeah, times cosine of k times angle plus I sine of this k times angle, if I am correct, if I remember well, you know? So it's as easy as that. And then you basically, yeah. So what we need to do is basically find the magnitude or radius of this complex number as well as its angle or degree. So what we're going to do first is find the r. So we know that a is basically 2, which is a real part, and b is basically 3, well, minus 3, so to speak. So to solve this, we're first going to find r, which is quite simply 2 squared plus minus square root of minus square root of 3. So this is going to be basically 4 plus 3, right? So our r is simply this, right? Now the angle is going to be tangent minus 1 b over a, as we already saw in the earlier video. So a is going to be basically over 2, right? Well, tangent of that. Sorry. Tangent of this. Tangent of this. Oops. And that will be, if we take out our calculator here, calculator, we already did the numbers here. It's basically 0.71. Well, approximate. This is an approximate, you know? So let's just do that. So what we're simply going to do now is put all of our values over here. So how does that work? Basically, yes, we have r to the k, oops, r to the k is going to be, let me just remove my calculator here, and we'll just copy this guy. Oops, we have low battery, guys. So we have low battery here. And that's basically going to be r to the k. So we know that r is 7. We know that k is 50. And then cosine of k, so 50 times tangent, well, this whole chunk over here. So I'll take this guy. We're going to make it smaller so it fits here. Yeah. Plus I sine of this thing again. Oops. Duplicate. And then after that, we'll just close this. Right? So once we have that, once we calculate that, we can just put it in our calculator. If we do that, so let's do that real quick. Open our calculator here. Let's do clear. So where do I clear here? Is it answer? Is it AC? Yeah, it's AC. So we can simply do square root of 7, and then we do this to the power of 50, and then we do, let me just turn off my battery saving mode, otherwise it's gonna turn off my screen. And then we do cosine of 50 times tangent of minus square root of 3 over 2. Close this up, plus sine, I think, plus like that. Let me just check real quick. Let me just check my answers here, guys. Give me a second. Uh-huh. Well, yeah, it's gonna be sine, yeah. Basically gonna be sine. This is gonna be the polar representation of that. Just give me a second. I'm just checking something really, really quick. It's a bit confusing, but I don't have it. I don't have it here. So just check our Blatt 1. This is basically what we have to do, right? Because I want to check real quick what I did. So yeah, we basically just do that. Yeah, I'm sorry, just wanted to like verify because I wasn't really that sure. So we continue on. Sine of 50. Well, yeah, sine of 50. We'll just calculate this first. We'll just calculate this guy first, which is a pretty big number. So we're gonna just write it down. It's gonna be approximately 1.34 times 10 to the 21, right? And then cosine of whatever we have here. So cosine of 50, cosine of 50 times tangent, or arctangent of b over minus square root of 3 over 2. And then we close that, and we do equal. So that's gonna be basically minus 0.42 plus, right? And now we do go here, and we do the same for sine of that. So that's beautiful, 0.93i, basically. Once we have that, that's pretty much what we need. And we can just multiply this simply like so. If we go back to my earlier solutions, as you can see, what I do here is once I have this big number, we can simply do that. Oh, okay, yeah, I get it. Now we just simply do that. We do it part by part. So we can simply say that again. You just look at this again. Yeah, we can simply say that minus 0.42 times square root of 7 to the 50th power plus 0.093 I times 50th power. And that's pretty much it. That's simply it. We could multiply it as well. So if we multiply this, let's check it out what we get. I'm gonna write it here. So let's just clear this out. It's taking longer than expected because I'm just messing things up, you guys. Square root of 7. And oopsie. And to the 50th power. That's gonna be basically minus 5.63 to the 10 to the 20th power plus, and then we do the same thing, but with 0.9903. And that's gonna be basically oh no, not minus, it's gonna be plus. So we just remove the minus and it'll be plus. So that's gonna be basically 1.21 times 10 to the 21. And that's pretty much it. I, of course, is I, and this is, yeah. So that's pretty much how you solve this. And yeah, that's pretty much it, guys. Thanks for watching.